Betelgeuse, one of the most renowned stars in the night sky, has been a subject of interest for astronomers and stargazers for centuries. Its distinctive reddish hue and enormous size make it a standout in the Orion constellation, easily seen from Earth without assistance. Betelgeuse, though, has been in the limelight recently for a different reason that has excited the scientific community: a sudden and dramatic 250% increase in brightness, as observed by the James Webb Space Telescope. This unexpected turn has raised intriguing questions about the star's current activity and ultimate fate. Betelgeuse is a red supergiant, a star close to the end of its life. Some 642 light-years from Earth, it is one of the largest and most luminous stars in the Milky Way, some 700 times larger than the Sun and over 10,000 times more luminous. Stars like this are renowned for being unstable as they near the final throes of their lives, and Betelgeuse has been no exception, with chaotic sky dimming and brightening cycles over the years. Yet this recent and most intense brightening is something astronomers have never witnessed and is a milestone for astrophysics. The James Webb Space Telescope, with its next-generation infrared technology, played a key role in the detection of this sudden change by peering through the thick clouds of gas and dust surrounding Betelgeuse. JWST provided scientists with an improved view of the star's surface and its surroundings. What it discovered was startling. Betelgeuse's brightness had increased by a staggering 250% within a few weeks. A rapid and unexpected change that meant something extraordinary was occurring within the star. The implications of this sudden brightening are extreme. Betelgeuse has been a supernova candidate for some time, the massive explosion that occurs when a supergiant star runs out of nuclear fuel. While this explosion is anticipated to happen at some point in the next 100,000 years, this fresh injection of energy makes one speculate that perhaps the time is arriving sooner than later. The star's recent unstable behavior, coupled with this new brightening, indicates that Betelgeuse is entering an even more unstable phase, one that could be a precursor to a catastrophic supernova. If Betelgeuse were to go supernova, it would be a celestial event that would be visible from Earth even during the day and would outshine the full moon for several weeks. Although the star is relatively close, such an explosion would pose no danger to life on Earth due to the vast distance involved. Instead, it would be a one-time opportunity for scientists to observe a supernova in the act, obtaining valuable information on the processes that govern the death of massive stars. Betelgeuse's new brightening also raises new questions about the internal processes of red supergiants. These stars are notoriously unstable due to their immense size and complex internal processes. Convective processes give rise to turbulent phenomena that even state-of-the-art models cannot account for. Betelgeuse, in particular, has puzzled astronomers for decades with its erratic light curves. The underlying cause of its abrupt 250% brightness increase might hold secrets about red supergiant life cycles and the physical processes governing their variability. One theory stemming from this occurrence is that Betelgeuse may have undergone a massive convective cell or hot gas bubble from the core to the surface. These convective events are common in supergiant stars and can create spectacular fluctuations in brightness as material is ejected off of the star's outer layers. If Betelgeuse experienced such a convective event, it would explain the sudden brightening of the star, as the expulsion of hot gas into space would temporarily light up the star. Another possibility is that Betelgeuse has shed a large amount of mass in the form of a stellar eruption, which has created a cloud of dust and gas that could be interacting with the star's light. In 2019, Betelgeuse experienced a mysterious dimming event, which some researchers believe was caused by a massive cloud of dust obscuring some of the star's light. This new brightening could be a reversal of this previous dimming event, with new material being expelled and heated up by the star's strong light. Another interesting scenario is that Betelgeuse's magnetic field may be behind these changes. Even though its magnetic activity is not well understood, recent studies suggest that the star can harbor a dynamic and complex magnetic field that can influence its brightness. The magnetic field changes could impact the manner in which energy transports within the star, resulting in rapid alterations in its luminosity. If this is the case, the current outburst of brightness may be due to a shift in Betelgeuse's magnetic activity, offering scientists a new avenue for exploring stellar magnetism. With Betelgeuse still under the watchful eye of astronomers, the sudden brightening also draws attention to the role of stellar mass loss in the life cycle of supergiant stars. Red supergiants like Betelgeuse are losing mass at a very high rate, ejecting enormous amounts of gas and dust into space. Mass loss is believed to have a significant impact on the subsequent evolution of a star, as it can influence the star's structure and stability. If Betelgeuse is actually losing mass at a higher rate, it could signal that the star is nearing a tipping point in its life cycle that would cause further instability and, eventually, a supernova. The timing of the event is also fortuitous for the field of astrophysics, as the James Webb Space Telescope continues to revolutionize our understanding of the universe. JWST's infrared light detection has opened up new avenues for monitoring faraway and obscured celestial bodies, and Betelgeuse's sudden brightening is a perfect target for its state-of-the-art instrumentation, allowing scientists to capture high-resolution images and data. The JWST now offers scientists a unique opportunity to study the complex activity of a red supergiant on the verge of its transformation. While there is a hype about Betelgeuse being poised to supernova, it should be noted that this present brightness uptick does not necessarily signal that an explosion is imminent. Red supergiants are notorious for their volatility, and Betelgeuse may simply be experiencing one of its many instability periods. That being said, the unprecedented 250% increase in brightness suggests that something extraordinary is occurring within the star. As astronomers hunt for the cause of Betelgeuse's spectacular brightening, this outburst underscores the dynamic and often tumultuous process of stellar evolution. Stars like Betelgeuse, which are nearing the end of their lifetimes, undergo a range of internal and external processes that can profoundly alter their appearance and behavior. It is important to learn about these processes not just to predict the future of stars like Betelgeuse, but also to discover more about the general processes that regulate the life and death of stars across the universe. Betelgeuse's explosive brightening is a reminder of the violent and unpredictable forces that are at work in the universe. Stars are not steady objects, they are dynamic systems that evolve and change over time. Betelgeuse, with its erratic luminosity changes, provides a valuable window into the complex and often turbulent processes involved in stellar evolution. One of the most exciting prospects of this discovery is that of follow-up observations. Betelgeuse is now being intently monitored by a suite of telescopes and instruments, including JWST and ground-based observatories. These observations will allow scientists to track the star's behavior in real time, delivering helpful information that could unveil the underlying reasons for its recent abrupt brightening. In the coming months and years, astronomers will be watching to see whether Betelgeuse's brightness continues to be variable or returns to normal levels. The implications of the event extend beyond Betelgeuse itself. Red supergiants are a typical star in the universe, and observing Betelgeuse's behavior can hold valuable insights into the life cycles of other giant stars. If researchers can decipher what is behind Betelgeuse's fluctuations in brightness, then they can apply that knowledge to other stars, which will help build a more complete picture of how supergiants live and die. This data would also shed light on the formation of supernovae, black holes, and other exotic objects that are crucial to the evolution of the universe. Beyond the scientific value, Betelgeuse's sudden brightening has also excited the public imagination, making us aware of the wonders of the universe and the mysteries yet to be solved. Betelgeuse has been a star shrouded in legend and myth for such a long time, associated with the figure of the hunter Orion by most civilizations. Its dramatic and unstable nature only adds to its mystique, continuing to intrigue and amaze scientists and the public alike. This recent rise in Betelgeuse's brightness is not just an astronomical anomaly but a mirror of the ever-evolving nature of the universe. Once thought to be quite predictable in its variations, Betelgeuse has now provided a dramatic reminder of how much is still to be learned about the life cycles of giant stars. The 250% luminosity increase that the James Webb Space Telescope has witnessed has left the science world buzzing, raising new questions about the internal mechanisms of these giant stars and their final fate. To fully grasp the importance of this event, it's essential to explore not only the scientific and technical but also the broader cosmic and philosophical questions it presents. Betelgeuse, a dying red supergiant, has been a fascinating object of study for a while now because it's irregular and bizarre in nature. However, this record-breaking explosion of brightness has forced scientists to re-examine current models of star evolution for supergiants. The sudden brightening raises fundamental questions about the forces at play within Betelgeuse that could cause such a drastic change. Like other large celestial bodies, Betelgeuse is governed by complicated interactions between gravity, fusion reactions, and magnetic fields, all of which may be involved in its ongoing explosion of brightness. One area where this phenomenon may provide valuable insight is in the study of stellar fusion. Nuclear fusion in the core of all stars, including Betelgeuse, creates the energy necessary to counteract the force of gravity pushing inward on the star. In a supergiant such as Betelgeuse, these fusion reactions are more involved than in lower-mass stars, such as our Sun, since the extreme temperatures and pressures allow for the fusion of elements heavier than hydrogen and helium. As red supergiants approach the ends of their lives, these fusion reactions become increasingly unstable, with the star attempting to fuse increasingly heavy elements. Ultimately, it reaches the stage where it can no longer generate enough energy to resist the tug of gravity, clearing the way for its ultimate collapse and, very likely, a supernova explosion. This latest brightening event offers a great opportunity to gain further insights into these final, violent stages of a massive star's life. The 250% brightening of Betelgeuse could be an indication of an explosive change in its fusion processes, including the fusion of heavier elements in the star's core. The shrinking of the core as it depletes its fuel could be making the outer layers respond dramatically to the internal changes, resulting in a massive ejection of material that temporarily increases the star's brightness. Here, the latest brightening may be the precursor to more violent internal convulsions, propelling Betelgeuse along its final path toward its destiny as a supernova. However, this brightening is not only a sign of an explosion to come, it also signifies the lesser-noticed consequence of mass loss in supergiant stars. As with other stars at this stage, Betelgeuse has been shedding mass steadily over time through